everyone, so we're moving on to the next part, which is all about the exponent laws. This is where we're gonna take a step back. We're no longer gonna talk about the long polynomials like 2 and 3 term polynomials, but instead we're gonna focus on some laws we have on monomials, so one-term polynomials. Now we've talked about what happens when we want to add polynomials, when we want to subtract them. Now let's go with the slightly more complex math of multiplication and division, as well as powers. We have a few rules. The first rule is the product rule. So this occurs when you're multiplying two expressions with the same base. So for example, this would allow for us to use the product rule. We have numbers, the coefficients don't matter. What matters is that they have the same base, variables, and they're being multiplied. And that's it. That's the only thing they need. Something like this would not allow us to use the product rule because of the fact that there is no common base. Um, at this point, before I continue, I just want to remind you that you should be downloading and following through with us while watching the videos. All right, so there's the notes that are attached to this. Make sure you're editing them and taking notes essentially. All right, so the product rule, I'm going to explain in words what you do with the rule, but then I'm going to give you an example to kind of break it down. So the product rule occurs, the way you do this is that you multiply the coefficients and you add the exponents. So the two bases that you had the same, you're going to add their exponents. So going back to the first example I gave you, 3x squared times 2x cubed. So these are being multiplied. So I'm going to basically split it into parts. I'm going to split it into one part that's just the coefficients and one part that's just the bases. So this and this are going to combine over here, and this variable and this variable are going to combine over here. So I'm multiplying their coefficients, so 3 is being multiplied by 2, and then the variables x squared and x cubed, they're going to be brought here, where, as I said before, we are going to add the exponents. So 2 plus 3. And then we end up with 6x to the fifth. Now, when you have these monomials being multiplied, it could help to just kind of reorganize everything into common terms, essentially. It's very similar to what we did when we added and subtracted, where we add like terms and all that, except this time we're we don't have we don't really call them terms, but they're parts of the monomial. So like we're going to combine all the coefficients into one area. We're going to combine all the x variable terms to one area. And if we had other parts involved, like maybe there was a y to the fifth here, we would see if there was any variables that go along with that. Otherwise, it would just stay by itself and not be altered at all. All right, so we'll do some practice. So here's 4 questions. Just simplify as best you can using the product rule when applicable, and we'll go over it in a second. All right. So in this case, so for question one you may notice has no variable. Um, so what we're going to do is we're going to do the same thing we normally do, except now 3 is going to be our base. So just like last time, if this was x squared times x squared, we would add the exponents. We're going to do the same thing here. So 3 squared times 3 squared ends up being 3, 2 plus 2, or 3 to the fourth. Now from here, you can actually plug this into the calculator to see what you get. But I'm going to leave it like this because this is what I want in the end. All right. Now for question 2, I do pretty much the same thing I said before. I'm going to first look at my coefficients. So I have two coefficients here, 2 and 4. So these are going to be multiplied to get me 8. The next part is going to be the s squared and the s to the 7th. So they're going to come here to be s2 plus 7, which I end up getting 8s to the 9th. Now, of course, as you practice these problems more often, you won't have to go through it's this many steps. You could probably do it much quicker than me, but again, that usually comes with practice. I usually recommend trying it first before you kind of like with the long setup drawn out, writing every step until you really understand it, and then you can kind of start cutting corners. All right, down to here. Question 3 is very similar to question 1, except there is one little caveat. There is no common base. The base 3 and 5 are not the same. I can't break them up or anything, so I'm going to just leave it, and that's it. You can plug in your calculator to figure out what it is. It's going to be whatever 25 times 9 is, but we don't need to worry about that. All right, down to here. So question 4, once again, we do the same thing we did for question 1. Negative 3 is our base, and then we're going to add the exponents. So this ends up being negative 3 to the 5th. All right, continue on with the next 4 questions. So once again, pause the video, work itself. We'll go over in a second. All right, so here there's no coefficient in front of the a, or at least it's technically 1. So there's a 1 coefficient here times by 2. So the coefficient is just 2. And then we combine this part. So we have a to the 5th plus the 2, because they're being multiplied by the product rule. And we get 2a to the 7th. Going down to question 6. So we have, this time we have 2 terms, 2 variables that we need to combine. So we're going to combine the s's first. S2 plus 7. And then we'll do the t's. So we get t4 plus 3. And we end up with s to the 9th, t to the 7th. All right. Going down to question 7. Same thing as question 6, but just a little bit longer. So I'm going to combine the x's first. These are my 2 x's. Now, of course, the product rule isn't just limited to 2 monomials. Even though I wrote it, it could be 2 or more. So this ends up being 4 plus 3. The y's here and here. So it's going to be y to the 5th plus y to the 3rd. So 5 plus 3. And then the last one, the z's. Z squared and z to the 1. So z squared plus 1. And all in all, I end up getting x to the 7th, y to the 8th, and z cubed. And then down here, same thing, coefficients first. So negative 6 times 12. So when you plug this into the calculator, you're going to end up getting negative 72. Then we combine the bases. X to the 5th plus 5 gives me negative 72 x to the 10th. Now really quickly, I want to actually go back to this question. We'll do this one. So there's one thing I didn't mention before in one of the previous ones. I believe in the first polynomial slide where I talked about degrees of polynomials. I didn't mention how you could do the degrees here. Basically, I said before that the degree of the polynomial is whatever the highest number is. So in a case like this, the degree would be 10 because the highest polynomial, highest exponent, is 10. Here, though, we have 3. So what would be the degrees? Well, the way we would do this is we would add all the exponents. 7 plus 8 plus 3. So the degree here would be 18. Now, we'll mention this later on when we get to the factoring part, but this actually does have a purpose as to why we would add these exponents and what the purpose of even calling this a degree. All right. So there's two more laws that we're going to go through, and hopefully we could get through this quickly. So the next law is the power rule. The power rule basically occurs when we have an expression that's raised to some power. So this would be an example of something that would use the rule. We have 3x squared, y to the cubed, and all of this is being raised to another power to the third. All right? So the way we do the power rule now is we're going to distribute that outside 3, that outside exponent, to each part of the monomial. So each part of that expression. The exponent's going to go to the coefficient and raise it to that power, and then you're going to multiply all the other exponents by that outside one. So going back to this, we're going to distribute the 3 to each term, here, here, and here. So we end up having 3 cubed, x squared times 3, and then y cubed times 3. So it's just being distributed across. And then we simplify. So 3 cubed is 27, 2 times 3 is 6, and 3 times 3 is 9. That's it. So here are the next set of questions. Pause video, work on itself. We'll go over in a second. All right, so for question 1, we're going to take the 3 and we're going to distribute to the 2 and the p. So we end up getting negative 2 to the third, and then p 5 times 3. So negative 2 to the third, when we plug that in, we end up getting negative 8, and then it becomes p 5 times 3, which is 15. Number 2, we take the 4. Once again, we distribute to each term. So we end up getting 3 to the 4th, x cubed times 4, and x squared times 4. So once again, doing the math, 3 to the 4th when we plug it into the calculator is 81. 3 times 4 is going to be 12, and 2 times 4 is going to be 8. Down here, distribute the 3. So negative 10 cubed, t 3 times 3, x 1 times 3. And we're left with negative 1,000 t to the 9th x cubed. And then question 4. So this one's going to be a little bit trickier. We're going to pretty much do the same thing. We're going to take the 2 and we're going to distribute to each and every term above the line and below the line. So yeah. So we end up getting 4 squared, a 5 times 2, b 1 times 2. This is being divided by 6 squared, a 1 times 2, be 3 times 2. So this leaves us with 16 up top, 8 to the 10th, b squared, and then this ends up being 36, a squared, b to the 6th. Now, the thing is, we actually can simplify this one step further. However, in order to do that, we would need our last rule, the quotient rule. So the quotient rule is when we end up having division. And just like before, it has to be division with the same base. So if we go back to that previous scenario, we actually do have the same base, a and b. Though I'm going to do this scenario here where we have 14x cubed divided by 2x squared. So this would also use the quotient rule. We have two expressions, same base, and then being divided. Alright, so for the quotient rule, you're going to divide the coefficients and you subtract the exponents. So we start with our expression here. So we take all the coefficients, move them to one side. So we have 14 divided by 2. And then the variable terms, the bases, they're going to go to a different side and we're going to subtract them. 3 minus 2. Because the 3 is in the numerator, 2 is in the denominator. And we end up getting 7x to the first. Alright. So here's the next set of questions. I know this video is going a little bit longer, but we'll be done soon. So pause video, work itself. We'll go over in a second. Alright, so again, we're splitting this in half. 8 divided by negative 4. And this ends up being x 3 minus 2. So 8 divided by negative 4 is going to give me negative 2. 3 minus 2 gives me 1. So my answer is negative 2x. Going here, so the coefficient is going to be negative 1 divided by negative 2. And then we're going to end up having y to the 7th minus 1. So this is going to leave me with 1/2 y to the 6th. Or you can write it as y to the 6th divided by 2. Same thing. Alright. Now for here, so we have the w's. So we have 5 in the numerator, 1 in the denominator. For the x's, we have 4 in the numerator, 2 in the denominator. The y's are going to have 6 in the numerator minus 4 in the denominator. However, there is one mistake that I made. There's an exponent out here. So actually, instead of doing 5 minus 1, I have to multiply that 5 by 3. I have to do the same thing for the 4 and for the 6. I know I'm got a little messy. Bear with me. So this ends up being 15 minus 1, 14. 3 times 4 is 12, minus 2 is 10. And 3 times 6 is 18, minus 4 is going to be 14. So a little bit on the messier side. Normally I would actually recommend distributing the 3 first before subtracting, just like with number 4. So I'm going to do the same thing I did in the previous set, where I'm going to distribute the 2 first. So we get 5 squared, g to the 4th, h squared, 20 squared, h, 1 times 2 is 2, and then 3 times 2 is 6. Then I'm going to simplify. So this ends up being 5 squared divided by 20 squared. We have 4 in the numerator, 6 in the denominator, and then we have 2 in the numerator, 2 in the denominator. When we plug this into the calculator, what we're going to end up getting is, I'm going to leave this in fraction form. It's going to be 1/16 g to the negative 2, and then this will actually end up being nothing. This will end up dropping out. So this is what we're left with. There are actually other ways that we can kind of clean that up and make it look a little nicer, but that's pretty much what we would end up doing. All right. So here's your exit question. There are three questions, three practice questions where you basically practice using one of these three rules, and then when you go down to question 2, what you're going to do is, once again, we have a practice solution to a homework problem by Sonia. She uses the three rules, but she made a mistake somewhere, and the goal is, where did she make the mistake? All right. If you have any questions, please let me know. Otherwise, I'll see you in the next video. All right. Good luck and have a great day.